Imagine you've just landed a job as a data scientist at a tech company. Your first mission? Dive into some data analysis using Python. To get rolling, you'll need to install and import NumPy, your trusty sidekick for numerical computing. If it's not on your system yet, a quick pip install will do the trick. NumPy is going to be your best friend for handling arrays and performing all sorts of mathematical operations efficiently. So let's go ahead and import NumPy, and we'll call it NP to keep things short and sweet. This step unlocks all the powerful functions and features that NumPy has to offer. Now, let me show you how to create your first NumPy array. Arrays are the heart of NumPy, and you can make them using the np.array function. Think of it like a Python list, but with superpowers for numerical operations. I'm going to create a variable called a, and use np_array to fill it with the numbers 1, 2, and 3. This gives us a simple one-dimensional array to start playing with. Great! You've just crafted a one-dimensional array. Now, let's see how to create an array filled with zeros. This can be super handy when you need a placeholder or a starting point for your calculations. I'm going to define a variable b and use np.zeros to whip up an array of 3 zeros. This function is your go-to when you need an array initialized with 0 values. And here's how you can create an array filled with ones. It's just like the zeros function, but starts everything off with ones instead. Perfect for creating identity matrices or scaling factors. Let's define a variable c and use np.ones to create an array of 4 ones. This is a quick way to generate an array where every element is set to 1. Now, let me tell you about the arrange function. It generates evenly spaced values between a start and a stop value. This is particularly useful for creating sequences or ranges of numbers. I'm going to create a variable d and use np.arrange to generate values from 5 to 14. This function is great for creating sequences of numbers with a specified step size. You can also create a fixed number of values between two endpoints using np.linspace. This is useful when you need a specific number of points between two values, such as for plotting or interpolation. Let's define a variable e and use the method np.linspace to generate 5 values between 0 and 1. This function is perfect for creating evenly spaced points in a given interval. Now that we've created a few arrays, let's check their dimensions, shape, and data types. Understanding these properties is crucial for manipulating arrays and performing operations on them. I'm going to print the shape, number of dimensions, and data type of the array A. This will give us insight into the structure and type of data we're working with. Let's calculate some basic statistics like mean, standard deviation, minimum, and maximum on an array with some missing values. I'm going to create a variable data with some missing values and use NumPy functions to calculate the mean, standard deviation, minimum, maximum, and sum, ignoring the none values. This is essential for accurate statistical analysis. We can detect missing values and even replace them. NumPy makes it simple to handle these missing values, which is crucial for cleaning and preparing data for analysis. I'm going to create a mask to identify the none values in the data array and replace them with the mean of the none values. This is a common technique for imputing missing data. Want to summarize along rows or columns? That's where the axis argument comes in. It allows you to specify the dimension along which to perform operations, providing flexibility in data analysis. I'm going to calculate the mean of the data array along both columns and rows using the axis argument. This demonstrates how to perform operations along specific dimensions. Let's clean up missing values by filling them with column means. This is a practical approach to handle missing data, ensuring that your dataset remains complete and ready for analysis. I'm going to create a new data array with missing values and fill them with the mean of each column. This technique helps maintain the integrity of your dataset by replacing nons with meaningful values. Let's talk about clipping and rounding values. These operations are useful for constraining data within a specific range or for simplifying numerical values. I'm going to use np.clip to limit the values in the data array between 2 and 5. This is helpful when you need to ensure that values stay within a certain range. Next, I'll use np.round to round the values in the data array to the nearest integer. This is useful for simplifying data or preparing it for presentation. Let's practice accessing individual elements, rows, and columns. This is a fundamental skill for manipulating arrays and extracting specific data points. I'm going to demonstrate how to access a specific element, a column, and a row from a two-dimensional array. This is essential for data extraction and manipulation. Let's try fancy indexing and boolean masking. These techniques allow you to select and manipulate data based on specific conditions, making your data analysis more dynamic and powerful. I'm going to create a mask to identify elements in the R array that are greater than 25 and use it to extract those elements. This is a powerful way to filter data based on conditions. Let's try some common element-wise mathematical operations. These operations allow you to perform calculations on each element of an array, enabling efficient data processing. I'm going to demonstrate how to apply logarithm, square root, exponential, addition, and multiplication operations on an array X. These are fundamental operations for numerical analysis. Now let's see broadcasting in action. Broadcasting is a powerful feature in NumPy that allows you to perform operations on arrays of different shapes, making your code more concise and efficient. I'm going to demonstrate broadcasting by adding a one-dimensional array Z to a two-dimensional array Y. This showcases how NumPy automatically expands the dimensions to match, enabling seamless operations. Let's measure the performance of squaring a large array X using the timeItMagic command. This will give us an idea of how efficiently NumPy handles large-scale computations. Please take a moment to like this video, as it is going to be a great help, and don't forget to subscribe to my channel. Let's try conditional counting and logical operations. These operations allow you to count elements that meet certain conditions and perform logical checks on arrays, which are essential for data analysis. I'm going to demonstrate how to count elements greater than 4, check if any element is greater than 10, and verify if all elements are greater than 0 in the R array. These operations are useful for data validation and analysis. I'm going to compare two arrays, A and B element-wise, to check for equality. This is a common operation when you need to compare datasets or validate results. Now let's explore matrix operations like dot products and transposes. These operations are fundamental in linear algebra and are widely used in machine learning and data analysis. I'm going to calculate the dot product of two matrices A and B using both np dot and the stat operator. This demonstrates how to perform matrix multiplication, a key operation in many algorithms. Next, I'll show you how to transpose matrix A and reshape it into a different shape. These operations are useful for reorienting data and preparing it for further analysis. I'm going to calculate a weighted sum of scores using weights with the dot product. This is a practical example of how dot products are used in weighted averaging and scoring systems. Let's talk about reshaping and stacking arrays. These operations allow you to change the shape of arrays and combine them, providing flexibility in data manipulation and preparation. I'm going to reshape an array R into a 2x3 matrix, then flatten it back to a one-dimensional array. This demonstrates how to change the structure of your data for different analysis needs. Next, I'll show you how to horizontally stack two arrays A and B, vertically stack them, and concatenate them. These operations are useful for combining datasets and building larger arrays. Let's wrap up with a real-world use of broadcasting: standardizing each column. Standardization is a common pre-processing step in data analysis, ensuring that each feature contributes equally to the analysis. I'm going to standardize each column of the data array by subtracting the mean. This is a practical example of how broadcasting simplifies operations across different dimensions. Thank you so much for watching this video. Don't forget to subscribe my channel and see you next time.